You are stuck to the earth right now. Not metaphorically, physically. An invisible force is pulling every atom in your body toward the center of a ball of iron and rock 8,000 miles wide, and it has been doing this without pause for every second of your life. You don't feel it the way you feel wind or heat because you've never experienced its absence. Gravity is the background hum of existence, so constant and so total that your brain edited it out of conscious awareness somewhere around the age of 6 months. You learn to stand, to walk, to pour water into a glass, to judge the arc of a thrown ball, all of it calibrated to a force of exactly 9.8 meters per second squared, pulling straight down, every second, forever. So what happens if it stops? Not weakens, not fluctuates, stops, completely, planet-wide, for exactly 1 second. 1 second, the time it takes to blink, the duration of a single heartbeat, the pause between the second and third word of this sentence if you're reading at a normal pace. Gravity disappears for that long, and then comes back, full strength, as if nothing happened. You'd barely notice, right? You might feel a weird little lurch, like an elevator hiccup, and then everything goes back to normal. 1 second is nothing. 1 second is enough to break the world. The first thing to understand is what gravity is actually doing at any given moment. Gravity is not merely holding you to the floor. It's holding the atmosphere to the planet. It's holding the oceans in their basins. It's compressing the tectonic plates against each other. It's keeping the molten iron core under pressure. It's maintaining the pressure gradient that makes air breathable at sea level. Every fluid, every gas, every loose object, every body of water on Earth is where it is right now because gravity says so. Remove that command for 1 second, and physics has to recalculate everything from scratch. Let's start with you. At the instant gravity vanishes, you become weightless. Not the simulated weightlessness of a parabolic plane flight where the aircraft is falling around you. Actual zero gravity. Your body, which has spent its entire existence resisting a downward pull, is suddenly pushing against nothing. If you're standing, the slight muscular tension in your legs that keeps you upright launches you gently off the ground. You don't rocket upward. There's no force throwing you toward the ceiling. But your muscles were exerting a small upward force to counteract gravity. And with gravity gone, that force wins. You drift upward. Slowly. Maybe a few centimeters in that first second if you were standing still. If you were mid-stride, walking or running, your trajectory gets more interesting. The horizontal component of your movement stays the same, but the vertical component that gravity was pulling back down is now free. A person mid-jog lifts off the ground in a low arc and doesn't come back down. For 1 full second, every human being on Earth is floating. But that's not the worst part. Look at the air around you. The atmosphere is a column of gas roughly 100 kilometers tall, held against the planet's surface by gravity. At sea level, that column presses down with a force of about 101,000 pascals, which is roughly 1 kilogram pressing on every square centimeter of your skin. That pressure exists because gravity is pulling the upper layers of atmosphere down onto the lower layers, compressing them. The air is denser at sea level and thinner at altitude, and that gradient is what makes breathing possible. Without gravity, that pressure gradient vanishes. Instantly. The compressed air at sea level is suddenly not being pushed down by the weight of the atmosphere above it. It begins to expand outward. Not explosively, not like a bomb, but rapidly. The lower atmosphere starts to equalize pressure with the upper atmosphere, which means it pushes outward and upward. In 1 second, the effect at ground level is modest. You'd feel a slight pressure drop, maybe equivalent to suddenly jumping to an altitude of a few hundred meters. Your ears might pop. Not dangerous by itself. But something much stranger is happening to every body of water on the planet. Oceans are held in their basins by gravity. Without it, water has no reason to stay in the basin. Surface tension holds small amounts of water together, but oceans are not small amounts. The water doesn't fly off into space because there's no force launching it. But it does something deeply unsettling. The pressure at the bottom of the ocean, which normally runs to about 1,000 atmospheres in the deepest trenches, drops towards zero. The entire ocean is suddenly an unpressurized body of water with no weight. The seafloor, which has been bearing the load of kilometers of water above it, is suddenly unloaded. The water begins to lift off the seabed, not flying upward, but separating, floating. The ocean becomes a hovering mass, disconnected from the ground beneath it. In deep ocean, the effect is surreal. In shallow coastal areas, the water lifts and spreads. Harbors empty slightly as water drifts outward. Riverbeds see their water lift and scatter. Lakes detach from their beds and hover as wobbling, shapeless masses. 1 second passes. Remember, we're still in that single second. Everything described so far is happening simultaneously, and none of it is the actual disaster. The floating, the pressure drop, the ocean lifting, these are the setup. The catastrophe begins the moment gravity switches back on. Gravity returns at full strength. 9.8 meters per second squared. Instantaneous. No ramp up, no gentle fade in. The universe remembers it has rules and enforces all of them at once. Every person who drifted upward during that second now falls. If you were standing still and rose only a few centimeters, you land awkwardly and stumble. Uncomfortable, but survivable. If you are mid-stride and lifted off, you come down at an odd angle and hit the ground wrong. Sprained ankles, broken wrists from bad landings. If you were jumping, running, or on a trampoline, you went higher and you fall harder. Gymnasts, mid-routine, drop from unexpected heights onto surfaces they weren't aimed at. Construction workers on beams and scaffolding floated off their footing and now fall back onto steel and concrete. Window washers on platforms drifted away from buildings and returned to gravity without a surface beneath them. The human toll is immediate and global. Not everyone is injured, but millions of people worldwide are in positions where even a few centimeters of unexpected vertical displacement, followed by a sudden fall, produces broken bones, concussions, spinal injuries. Hospitals will fill within the hour. But that's not the worst part. The oceans fall back. Trillions of tons of water that spent 1 second hovering above the seabed slam back down under full gravity. This is not a gentle settling. This is the largest body of water on the planet performing a belly flop. The impact generates pressure waves that propagate through the water in every direction. Along every coastline on Earth, the ocean's return creates a displacement wave. Not a traditional tsunami caused by a seafloor earthquake, but something functionally identical. Walls of water pushed outward by the sheer violence of the ocean reconnecting with the ground beneath it. The waves aren't uniform because the ocean didn't lift uniformly. Shallow coastal shelves had more dramatic separation than deep ocean basins. The worst effects hit areas where the continental shelf is wide and shallow, places like the North Sea, the Gulf of Mexico, the South China Sea, the Bay of Bengal. Coastal cities in these regions see surges of 3 to 10 meters within minutes of gravity's return. And we haven't even talked about what happens to the water that was already in motion. Every river on Earth just had its flow interrupted for 1 second. Rivers work because gravity pulls water downhill. For 1 second, that pull vanished, and every river on the planet stalled, its water lifting slightly off the riverbed and spreading laterally. When gravity returns, that water doesn't resume flowing smoothly. It crashes back into channels that may have deformed during the unloading and generates flash floods along every major river system on the planet. The Mississippi, the Yangtze, the Ganges, the Amazon, the Nile. Every single one experiences a simultaneous flood pulse as water that spent 1 second drifting is suddenly thrown back into a channel at the speed gravity dictates. But that's not the worst part. Think about what's under your feet. The Earth's crust is a collection of tectonic plates floating on semi-liquid mantle rock, held in compression by gravity. Every fault line on the planet, every subduction zone, every mid-ocean ridge is in a state of equilibrium maintained by gravitational pressure. For 1 second, that pressure vanished. The plates didn't fly apart, but they shifted. Microscopically, in geological terms. But in earthquake terms, microscopic shifts along fault lines that were already under stress are not microscopic at all. When gravity returns and recompresses the plates, every fault line that was close to its failure threshold gets pushed past it. The Cascadia subduction zone off the Pacific Northwest, the San Andreas Fault, the Hellenic Arc beneath the Mediterranean, the Japan Trench, the Himalayan frontal thrust. All of these faults carry accumulated strain measured in decades or centuries of stored energy. The 1-second gravitational interruption doesn't release all that energy immediately, but it destabilizes the system. Within hours of gravity's return, seismographs worldwide begin registering increased activity. Within days, the first major earthquakes begin. Within weeks, the planet is experiencing a cascade of seismic events as fault after fault releases stored energy that the gravitational interruption nudged past the breaking point. And we haven't even talked about the underground water. Aquifers, the underground reservoirs that supply drinking water to billions of people, are pressurized systems held in equilibrium by the weight of the rock and soil above them. 1 second of zero gravity unloaded that weight. The water in those aquifers expanded slightly, shifted, pushed into cracks and voids that were previously sealed by pressure. When gravity returned, the overburden crashed back down onto aquifer systems that had momentarily rearranged themselves. The result is thousands of sinkholes opening worldwide as underground voids that expanded during the zero-gravity second collapse under the returning weight. Florida, which sits on porous limestone riddled with aquifer cavities, would be devastated. Mexico's Yucatan Peninsula, built on similar geology, the same. Parts of China where underground water extraction has already weakened the substrate would see entire neighborhoods swallowed as the ground gives way. The atmosphere, too, pays a price on return. The air that spent 1 second expanding outward is suddenly recompressed by gravity. This creates a pressure wave that travels across the planet's surface at the speed of sound, roughly 1,200 kilometers per hour. Not strong enough to flatten buildings, but strong enough to shatter windows, set off car alarms globally, and cause ear-damaging pressure spikes in people who were in enclosed spaces. Anyone in a tunnel, a subway station, or an airtight room experiences a sharp compression event that can rupture eardrums and cause severe disorientation. Aircraft in flight experience it as sudden severe turbulence, a violent jolt as the atmosphere they were flying through hiccuped around them. Planes that were on final approach, gear down, lined up with the runway, find themselves in air that is momentarily the wrong density at the wrong altitude. The autopilot corrections are frantic and, in some cases, insufficient. Now step back and look at the full picture of what 1 second just did. In the immediate aftermath, hospitals everywhere are overwhelmed with fall injuries, ranging from bruises to fatal spinal trauma. Coastal cities are flooding from displacement waves. Rivers are overflowing their banks. Sinkholes are opening. The atmosphere delivered a planet-wide pressure slap. And all of this happened in the first few minutes after gravity came back. But the longer-term cascade is worse. The earthquakes build over weeks. Faults that were stable for centuries begin slipping. The seismic cascade triggers secondary disasters. Landslides in mountainous regions. Dam failures as reservoir walls crack from the combination of water displacement and ground shaking. Volcanic systems that were held in check by overburden pressure begin showing increased activity as the 1 second unloading event allowed magma chambers to expand microscopically, reducing the pressure cap that kept them sealed. Volcanologists would watch in real time as monitoring stations around Yellowstone, Campi Flegrei, Tal, and dozens of other systems begin registering increased thermal output and gas emissions. Not necessarily eruptions, but the threat of eruptions, which forces evacuations, shuts down airspace, and paralyzes regional economies. The ocean effects compound. Remember the oceans? The initial displacement waves were just the beginning, and this is where the delayed bomb goes off. When trillions of tons of seawater slammed back onto the ocean floor, it didn't just create surface waves. It generated massive pressure pulses that propagated through the water column and hit the seafloor like a planet-wide hammer strike. Submarine geological features that had been stable for millennia, underwater cliffs, sediment shelves, volcanic slopes, received an impact load they were never tested against. Underwater landslides begin within hours, and each one generates its own secondary tsunami. The coast of Norway, which sits above the remnants of the ancient Storegga slide, one of the largest known submarine landslides in history, sees sections of its continental shelf give way. The resulting wave arrives at the Scottish coast with almost no warning. Meanwhile, the disruption to deep ocean circulation patterns caused by the momentary separation of water from the seafloor takes months to stabilize. The thermohaline circulation, the great global conveyor belt that moves warm water from the tropics toward the poles, stutters and destabilizes. Nutrient upwelling patterns that drive marine ecosystems are disrupted. Fisheries that depend on predictable ocean currents see catches plummet as the biological systems that rely on those currents struggle to recalibrate. Coral reefs, already stressed, experience sudden temperature and pressure shifts that trigger mass bleaching events across entire ocean basins. Infrastructure damage becomes visible in the weeks following. Buildings that appeared undamaged develop cracks as the stresses from the float and drop cycle work through structural materials. Concrete, which handles compression well but tension poorly, was subjected to a momentary tensile load as the building's own weight briefly vanished and its structural members, pre-compressed under normal gravity, relaxed and then recompressed. Bridges, particularly long-span suspension bridges whose cables are calibrated to specific gravitational loads, show fatigue damage. Pipelines, especially buried gas and oil lines, cracked at joints during the ground movement associated with the returning gravity. Gas leaks and small fires become epidemic in the weeks following. But that's not the worst part. The worst part is that none of this was caused by the absence of gravity. 1 second of weightlessness by itself is harmless. Astronauts on the International Space Station live in continuous zero gravity for months and suffer nothing worse than muscle atrophy and bone density loss over long periods. 1 second of floating would be fun, a novelty, a weird little hiccup in the day. Everything that breaks, everything that floods, everything that collapses, everything that cracks and shifts and ruptures, all of it is caused by gravity coming back. The return is the weapon. The planet spent 4.5 billion years arranging itself according to the rules of gravitational compression, every rock and ocean and gas molecule finding its place in a hierarchy dictated by mass and distance. 1 second of freedom let everything shift just enough that the return to those rules produced catastrophic mismatch. The ocean wasn't in its basin anymore. The air wasn't in its pressure gradient. The faults weren't in their locked positions. The aquifers weren't in their sealed chambers. And gravity came back and said, all of this needs to be exactly where it was. And the violence of that correction is what shatters things. This is what makes the thought experiment so unsettling. It wasn't a disaster that arrived. Nothing was added. No asteroid, no explosion, no external force. Something was subtracted, briefly, and then put back. A rule was paused and unpaused. And the damage comes entirely from the fact that complex systems held in equilibrium cannot tolerate even a momentary interruption. The equilibrium isn't a resting state. It's a held state, maintained by constant force. Remove the force for 1 second, and the system drifts. Restore the force, and the system doesn't drift back. It crashes back. And crashing is never the same as settling. Years later, the geological effects are still being felt. Earthquake swarms continue along faults that were destabilized. Coastal infrastructure is being rebuilt with a new understanding that harbors and seawalls need to withstand forces nobody previously imagined. The global internet, which relied on submarine cables lying undisturbed on the ocean floor, has been partially rerouted through satellite networks because repairing every damaged cable is a decade-long project when the seafloor itself shifted during the event. Insurance industries have collapsed and reformed because no actuary table in history priced in planetary gravitational interruption. The psychological aftermath is its own category of damage. Billions of people experienced a full second of weightlessness, followed by a violent return to the ground. The event lasted 1 second, but the memory of it lasts forever. A generation of children develops a specific phobia that psychologists will eventually name. Fear of the ground disappearing. Fear that the invisible thing holding them down might blink again. Rates of anxiety disorders spike worldwide. Trust in the physical world, the unspoken assumption that down stays down, has been broken. And a broken assumption, once shattered, doesn't heal the way a bone heals. It stays broken. You just learn to live on top of it. And somewhere, a physics professor is standing in front of a lecture hall, explaining to students who lived through it that gravity is the weakest of the 4 fundamental forces. Weaker than electromagnetism, weaker than the strong nuclear force, weaker than the weak nuclear force, the feeblest interaction in the universe. And 1 second without it broke everything. 1 second. Not even long enough to finish saying the words, "Oh no." Long enough to rearrange the surface of a planet, reshape its coastlines, destabilize its geology, and remind every living thing on it that the ground beneath their feet was never solid. It was held. And held is not the same as stable. Held is a continuous act. Held requires a force that never, ever stops. And for 1 second, it did.